Okay, welcome back to trigonometry. We are going to be looking at how to graph a polar coordinate graph. So we have r is equal to 3 minus 4 sine theta. The instructions are we are to graph this on an r theta Cartesian graph. Okay. We are to graph this on a polar graph. Okay. And in this case, it will be possible, it will be necessary to determine where r crosses the origin. Where does r cross the origin? Enters the origin. Okay. And between 0 and 360 degrees. Okay. So we're going to go ahead and figure that out. All right. The problem we have here is 3 minus 4 sine theta. So we're going to go ahead and draw ourselves an r. We want 3. Um, we want an r theta axis in Cartesian coordinates. So it's going to look something like this. 1, 2, 3. Okay. And I'm going to draw a little dotted line around the 3 because this whole graph could be rewritten as negative 4 sine theta plus 3. This 3 is a vertical shift, so we're going to move everything up by 3. This negative 4 flips the graph. It reflects it, so we have to go upside down. So we're going to go between 0 and 2 pi. Here is my pi. Here's my pi over 2. Here is my 3 pi over 2. All right. So we're going to have an amplitude of 4. So I'm going to go ahead and count this 1, 2, 3, 4, 5, 6, 7. We have a negative 1 down here. So let me go ahead and dot this pieces in here. So we are going to go at 3. At pi over 2, we're going to be at sine of pi over 2 is 1. So we have negative 4 plus 3. That's going to give me a negative 1. Back to pi. So we're going to say sine of pi is 0 plus 3. We're going to be back up here at 3. At 3 pi over 2, that's going to be negative 1. So negative 4 times negative 1, that's going to be positive 4 plus 3. We're going to be all the way up here at 7, and then we come back down here at 2 pi. So for me to draw this thing in, we're going to have a sine wave, and it's reflected about my vertical shift values here. Okay, so that's what we've got. Now, the next thing that we're going to do is we're going to graph this in polar coordinates, okay? So we're going to go ahead and draw ourselves a polar coordinate graph here. This is 0, here's pi over 2, here's pi, here's 3 pi over 2, okay? Just going through and doing that. So at 0 degrees, right, or 0 radians, we're going to say that the value of my sine, the value of r, is simply going to be 3. So we're just going to say this is 1, 2, 3, right? Now, when I'm going up to pi over 2, something happens, right? It actually goes negative between 0 and pi over 2. So somewhere in here, it actually goes negative. So instead of looking at pi over 2, right, as straight up, it's going a negative 1. So we have to go negative 1 steps. We have to go 1 step backwards in the direction of pi over 2. Here's my pi over 2 direction. I'm going to go 1 step backwards. We're going to be down here somewhere. Okay, so there's my 1 there. Okay, then we're going to come back out. At pi, we're going to be back over here at 3. So we have 1, 2, 3. So we're going to be sitting up here at 3. Now, at pi over 2, we're going to be 7 steps in the pi over 2 direction. Let me go ahead and erase some of this stuff a little bit. So we're going to say here is my 3 pi over 2. We have 1, 2, 3, 4, 5, 6, 7 steps in my pi over 2 direction. Pretend that's straight. Okay, and then we're going to go back up to our 0 degrees, our 2 pi degrees. So we're going to be up here somewhere. Okay, so here we go, something like this. All right. So what this thing is going to look like is that we come in here and we cross the origin, we come across, we're going to escape this area, and we're going to be able to meet 3 points in our pi direction, and we're going to bring that down like that. Okay, hopefully your picture is going to be a little bit nearer than mine, but that's the general idea of what we want to draw. This is a line escape with an interior circle. So this is how you would draw this thing in polar coordinates, right? The next thing that we're going to do is we have to figure out where the heck does this thing cross. So we have 3 minus 4 sine theta equals 0, all right? And we have to go ahead and solve this. So this is going to be 3 equals 4 sine theta sine of theta is equal to 3 over 4. And then what we're going to have to do now is say that theta is equal to the inverse sine of 3/4. Now, I told you guys you're allowed to do this in degrees. So what I'm going to do is go ahead and sort that out. So I'm going to go to mode and put this thing in degrees. You could do it in radians too, but I'm going to put it in degrees because it's a little bit easier to think in degrees. And we're going to say we want the inverse sine, there we go, of 3/4. 3 divided by 4 here. Enter. Right? Let's go with, oh no, I want the sine of 3/4. I want the inverse sine. That didn't look right. Inverse sine of 3 over 4. Okay, we should be getting some kind of degree value here. Right, 48.59 degrees. So we have theta equals 48.59 degrees. Now that's where it happens in the first quadrant. That would be right here. Okay, if we were looking at the first quadrant, that's fine. So we could look at it right here. It's going to go, um, where are we? Yeah, that's going to go over here. Then it hits our pi over 2, but then it comes back out, and that's going to be between pi over 2 and pi. So somewhere in the second quadrant, it escapes. It's it's no longer negative. It turns back to being positive. So we have to figure out where it is in the second quadrant. Well, this problem here, 48.59 degrees, is in our first quadrant. So what we're going to do is we're going to say 180 minus this 48.59 degrees. We'll say 48.59 degrees. And we'll say, okay, theta 1 is going to be 48. Theta 2 is going to be, what do we have here? 131.41 degrees. So 131.41 degrees. And those are the two angles where this thing hits the origin. So that would be it's coming in at 48.59 degrees, and then it's leaving at 131.41 degrees. Okay. And that's what I'm looking for you guys to graph a polar coordinate curve in polar coordinates. But the goal is we're going to draw it in Cartesian coordinates. We're going to take our Cartesian coordinates, draw it in polar, and then we're going to figure out if there's any other features that I would want to know about. I'm going to ask those. It's usually where does it cross the origin? All right. I'm going to say thank you very much for watching. I will see you in the next video. Good luck.